Hi, as you can see here, we have got few code snippets I have written down to explain how a final keyword with variables and methods and classes look like. See, this is just a class, whatever be in it, a class, and before the class keyword, you just append a final keyword like this in lower case. And with a variable, you just append before the data type, whether it's int or float, whatever. You append final here, a string, whatever, a car, whatever. You can append a final before the data type for variables. And here, this one is an undeclared one, uninitialized one. This is an initialized final variable, undeclared static. So static final, if you're making it a class variable, not an instance variable, a class variable, and you want to declare it final, that is, you do not want to change its value, you want to keep it constant throughout the program. So this should be the order, static and then final, not final static. That will result in an error. Static final. Okay. Before final, public can come, access modifier can come, like public final or public static final, right? I mean, if you want to append public here, an access modifier or protected, whatever, you write it here before static, or if static is not there, just before final. Alright, and with a method, you just append final before the return type, final void display. Supposedly this is a method. This is how you use final keyword. And in the context of that, here I have got a program to explain this is a final int salary, final uninitialized variable, and yes, we initialize the variable. If you have written, I mean, if you have declared a variable to be final, but you have not initialized it, because it should have a value, right? Otherwise it will not compile, it will throw an error, because final is dealing with a value that should be constant. So you need to initialize the value. So if you did not initialize here, you can do it in the constructor or in the static block that I'm going to show you, right? So because you need to have access to the value. Here we have got a constructor initializing the value, we have got a method here displaying that value, we have got a main method in this class, and I create an object I of this class and I call the method show, which needs the value salary to display. So here, as the constructor is created, I mean as the object is created, the constructor is invoked, which is this, and here this value get initialized. This, so this salary is this salary, right, which is getting displayed here. So that is how we initialize an uninitialized final variable. Yes, and alright, here we have got, no, where is that static code? Yes, this is the static code which I had been explaining while explaining static blocks. So here you can see implementing an initialized static final variable. If we declare a static final variable and not initialize it right away, this variable can only be initialized inside a static block inside the code. If it is declared static, it should be initialized in the static block, right? And if it is not static and you want to initialize it, you use the constructor. Okay, so here we have got a class. I explained this to you, but in the concept of with the concept of static final, let me explain it. We have got a class here, employee. We have got a variable here, uninitialized static final, data type int, and we have got a static code that will definitely execute without object creation. So this value gets initialized upon the code running at runtime. Loading in the memory, instantly this block gets executed and value initialized. And we have got a method here displaying this value. We have got a main method here and an object created of this class. And when object is created, constructor is invoked, but we do not have any constructor here, so no issue. Nothing to do about a constructor. Then we have got that this method we invoke with the object, and here this value gets displayed only because it was initialized in the static block. Otherwise, if it had not been initialized, it would have thrown an error. It wouldn't have compiled. Okay, so final variables I've covered. Now here I've got a piece of code to show you. Another piece of code where we have got an uninitialized variable declared here of type data type int, and it is final, and it is getting initialized in the employee in the constructor. Yeah, the purpose of this code I'm going to shortly state it. Just let me execute the code here. We have got a class here. We've got a class employee, and we have got two methods here. Show method displaying a message with the value empid, and a main method here. And we create an object of the employee class and we pass a value. And we have created that kind of a constructor with one parameter of int type, and this value gets initialized to assigned to this. Through the constructor we are initializing the value. Now, why through the constructor? We could have simply initialized it here, but there is a need for constructor here because employee ID is changing. Like we need employee ID for one person is constant, but for 2-3 persons they're different, right? And if we want to display, say, some 4-5 persons employee ID, we want to display. So in that case, we simply change the value here, and it will get displayed every time. We need to run it every time we want to display an employee ID is an employee's employee ID, right? When it gets initialized, and then we invoke this method here through the object, and it gets displayed here. But we can also do one thing at runtime. We simply we needn't change code and compile and run again and again to display, right? Like changing every time the value here, that is not convenient. Then you save again in the bin folder, then you recompile, then you uh, re-execute it with the Java commands. Instead, at runtime, we simply run with one command, Java employee. Employee having the main method here, so Java employee and and we can give the employee ID there itself with a space, an integer digit, right? And how do we collect it through the coding? So we keep a scanner class here. So for scanner class, we need to import java.util. I have introduced you to scanner class and util package, in my star patterns. So it's the same statement to import java.util package where this class is there, scanner class. So in order to be able to use this class, I imported the package. So we create an object of the scanner class which takes an argument system.in. I told you as a buffer stream it takes, and then it passes and processes it. With the next command we convert it to an int, if it is an int, of course. So sc dot next int, it takes the value in n, and here we pass n, right? This piece of code we write here in the main method before we are creating the object. You can have these two lines of code before we are creating the object, right after the braces, and it will collect the value of the employee ID and assign it to n, and that n we pass here. And when we call the show method, that value gets displayed. This n gets passed through UID and it gets assigned to employee ID, which gets displayed here. So that is the utility of final keyword, final variable, declared but uninitialized, and yet we want to have the value as a constant. Now we use a final keyword with a class and show what happens if we try to extend a class declared final. So we have got a public class Ritu and we declare it final, and we have got a method here, comment, and displaying a message, I am inside class Ritu. And we have got another class Rituparna, that is my name. There is a short form and that is the full name. So this class is extends Ritu, and we have got a main method here. We create an object of this class and we call the method comment method of the class we are extending, and we get a compile time error as this is final. We simply remove it to extend it properly, to compile it. But if it is with final, it won't compile because it is final class we are trying to extend. So we cannot. Okay, we are calling this method which will be accessible to this class since it is extending we are inheriting the properties in this class, but because it is final we cannot extend the class. And we have got here another example with a method, final with a method. Here we have got a class A public class A. We have got a void final demo method which has been declared final. This method is displaying a message, and we have got a class A extends A, this class. No problem, because this is not final here, it is correctly extending. And and say we have got a main method. We are creating an object of this class, and we are invoking the method final demo here, but it won't compile because we are trying to override a method here. We have extended successfully because it is not a final class, but we are trying to override a method. Oh no, oh, I missed this. Oh, no, we have not overridden the method, but still it won't compile because this is final. Even if you override the method, still also it won't compile. See here, we have overridden the method, right, like this, in the class before the main method starts. This class, this method, we override here, we write it like this I have shown it with a star here. It won't compile. Even without this also it won't compile. Because this is a final method. Okay, and a final method that we're trying to invoke without overriding it. Okay, so this was all pertaining to final. Now we will be coming to abstract classes in the next video.